So here's a nice trick to use when you have square root of x as u. And I want to save the final answer. We already solved this once with this method. But I want to show you that you get the same answer doing it slightly differently. So what we're going to do is, instead of applying the d operator on both sides as this, you can choose to square both sides, just like that, and then apply the d operator after this. Now that's an interesting approach because you no longer have to differentiate square root of x. You only have to differentiate u squared. That's a lot easier than differentiating square root of x, right? Okay. So tell me what du squared is. What would that be? Or let me ask it differently. If you have d of some function, what are you supposed to write? What do you compute first? D of a function, what do you do? Take the derivative first and then attach d of what variable that is.
So df.
D, right? Okay, so if you do that, what do you get? What's the derivative of u squared?
2u.
2u, right? Everyone knows x squared differentiates to 2x. That's like the basic thing you learn in Calc 1, right? So this is going to be 2u, and then what do I attach? du. Okay? Now, the end result is kind of amazing. You skipped actually two things. One is, first, you didn't have to do this derivative of square root of x thing, which was actually more challenging than this, which everyone knows, right? Second is that you didn't have to solve for dx because it's already solved for dx. So two parts that was necessary when we actually have to differentiate both sides can be skipped if you do it this way, right? And now let's change this. This is u, that's u, so it's sine of u over 3u, and dx is this 2u du, and already you see that this is what you're getting. 2 over 3, bring it out. 2 over 3. Sine of u du, and the antiderivative sine of u is negative cosine. And then plug in square root of x, and you get the exact same answer. So that's a nice way to save time in solving a u substitution problem where you have a square root on one side. So the tip is square it so that you don't have to deal with the square roots.